Welcome to Basic Biostatistics 2 and to the last model number 10, where we're going to talk about survival analysis, where I'm going to give you a short, quick introduction about how to run log-rank tests, Kaplan-Meier curves, and how to perform survival analysis and to interpret the data. Survival analyses are used, for instance, if you'd like to predict or to know what are predictors of death, or whether you would like to compare survival curves among several categories. For instance, we'd like to know if there's a difference in the death outcome between the different physical activity categories. If, for instance, the people with low physical activity, or in our case the dwarfs with low physical activity, have a lower or higher survival compared to dwarfs who have high physical activity. First of all, in analyze, we have defined here after forecasting survival functions. What we're going to use is Kaplan-Meier and Cox regression. For the theory of Kaplan-Meier curves and log-rank tests, I refer you to the theory part or to theory books. And we also find Cox regression. What Kaplan-Meier does, if you select Kaplan-Meier, it compares if there's a difference in survival outcome or survival curves between categorical variables. For instance, in our case, we like to see whether there's a difference in survival among the three categories of physical activity. We select death outcome as status and define the event. The event is what's the event of death. We have coded that 0 is alive and 1 is death. That's the outcome is 1. The value indicating the event has occurred, in this case, is 1, which is a single value. If this dwarf is coded as 1, he has died. We continue. Then, as its survival function, we have to give the survival time, and we have here time of follow-up in regard death. So we add this variable to the timeline, and now we define the status and the survival time, because every dwarf will contribute a different survival time based on if he's alive or when did he die. The factor list, which compares us the three groups, this physical activity category, we add physical activity category to the factor, and now we have defined the model. What is missing, as we'd like to compare if there's a difference in the curve, we have to go to compare factor, and we have to select the log-rank test, which helps us or tells us whether the survival curves are different. We click and continue, we go to options. In options, I'm interested in the survival plots to see how the curves are. Survival tables we're not that much interested in, so we can leave it out. We continue, click on OK, and SPSS will give us several tables. First of all, we have a case processing summary table where we have written that we have 12 dwarfs with low physical activity, 37 with moderate, and 11 with high physical activity. We have a means and medians table for survival time. Median value in survival analysis means that 50% of the people are alive and 50 have died. That's the median survival time. For low physical activity, it's 16.8 years, for moderate 16.4 years, and for high physical activity 17. We have the lower and the upper bound, estimates, and some additional information. From this we basically see that the survival time, so the median survival time is, or the mean survival time, and here the median survival time is pretty much similar for the three physical activity groups. So once again, on the left side we have the mean values, and on the right side we have the median values. Finally, we have the results of the log-rank test. The null hypothesis is that there's no statistical significant difference in the survival curves between the three categories. Our p-value is 0.902, which means that we accept the null hypothesis. This means the survival functions, the survival curves of the three different groups of physical activity do not differ from each other. To see them graphically, we have here the survival function, and we see actually the three lines or curves are pretty much congruent. Thus, it doesn't matter if the dwarfs are physically active or no in regarding mortality, but the same outcome in regarding mortality. Thus, the Kaplan-Meier curves compare curves and tells us whether the difference in mortality outcome between categories. Now, similar then to the logistic regression analysis, we would like to know what are predictors of death. In order to know, for instance, if physical activity is predicting death, or if body mass index category can predict death, or what other factors can predict death as an outcome. We close the output file and we go again to analyze, into survival analysis, and this time we choose Cox regression model. Cox regression model is similar than the odds ratio and logistic regression, tells us the risk of death during a certain period of time based on some independent variables. For instance, you would like to know the risk of death for the different BMI categories and maybe food and vegetable intake and smoking status. First of all, we select death as an outcome, add it to status. We define event 1 when the event has occurred. We add the time of follow-up in regard death to the time, and then we add the covariates. So smoking status is one of the covariates. We are very interested in food and vegetable consumption probably, and we like to know whether BMI categories can predict death. Like in logistic regression, we first have to define the program which of the variables are categorical. So we click on categorical, we select BMI category, and we select smoking category as these two variables are categorical. I would like to have as a reference category the normal weight dwarfs, which is the first category. That's why I click here on first and click on change. The same I do for smoking, as I'd like to have that non-smokers are the reference category, knowing if you become smokers what's the risk of death. Once done, we click on continue and we go to plots, where we can ask a plot of the survival for instance 3 BMI categories. We click on BMI category and ask for separate lines, and we click on continue. In options, we can select the confidence interval for the hazard ratio as the results will be, and click on continue, and we run the survival analysis. The output file gives you this following pictures or tables. First, it gives you as usual a case processing summary with how many events occurred during the follow-up, how many cases censored, how many total observations. We're going to have a description of the categorical variable, how they were coded. 1 is no, 2 is yes, 1 is normal weight. In BMI category, 3 is obese. And then it starts with the blocks as in logistic regression. In block 1, with all the models, it gives you first an omnibus test of the model coefficients, and this tells us basically in the overall score if the model is statistically significant. The model calculates the chi-square value, and with a degree freedom of 4, which is a p-value of 0.000, it's far less than 0.05. This means that the model is statistically significant. In order to know, okay, what are the hazard ratio, which is similar to the interpretation than the odds ratio, we can see at the variables in the equation table, where we have the variable smoking, food intake, BMI category for normal weight, overweight, and obese, and their respective values. These are basically the values before having this hazard ratio. The valid value is the test result. For degree freedom of 1, it gives you the p-values. We see that smoking has a p-value of 0.00, which means that smoking is statistically significantly related to death. So smoking can predict death as an outcome. The hazard ratio is 6.89. This means that if you change from non-smoking to smoking, the risk of death increases 6.89 times. Thus, in dwarfs, at least in regard death, they should stop smoking, as smoking increases the risk of death. Fruit intake if you have a look at the p-value 0.72, meaning that food intake is not really related or is not really a predictor of death in dwarfs. The BMI category variable, we see that this is the reference category. So BMI next category is overweight, and the last one is obese. For overweight, in comparing with the normal weight category, the hazard ratio is 2.159, which means if you're overweight, you have a 2.159 times higher risk of death. However, this increase is not statistically significant as the p-value is 0.119. However, if we check the obese values and compare to the normal weight category, the obesity is a significant predictor of death, and the hazard ratio is about 3.78, which means that if you're obese, you have a 3.8 times higher risk of death compared to dwarfs that have normal weight. The 95% confidence interval for the hazard ratio ranges from 1.46 until 9.78. Thus, smoking and BMI category and obesity are predictors of death. We could now basically run different models, exclude food intake, and see if you have a better model or how much the hazard ratio changes. If you'd like to see the survival plots, we can go down and we see here like the survival function of mean of covariance, the general survival function of the dwarfs, and in the end we see basically three curves of body mass index category as you have chosen compared to the normal weight. The reference curve in blue is the survival of the normal weight at the highest survival, because after 20 years of follow-up they have a survival of 0.7. Dwarfs, who are obese, have a survival of only 20%, and overweight ends up with about 40%. This is, as a short introduction, survival function and Kaplan-Meier curves. You can make different kind of graphs. You can select log rank, you can hazard curves, select 1 minus survival to see what the different curves, how the different curves will be. I hope you understand now how to do survival analysis in SPSS, or at least in a simple way, how to interpret the results of the tables. And I hope that you'll be able to do the quiz and the exercises. Any problem you have, I'm waiting for emails, or you can contact me on Skype. I wish you have a great day, and I hope you enjoyed this course. Thank you very much. Bye bye.